Hello, my name is Stephen Goldfarb, and I'm a physicist working on the ATLAS experiment here at CERN. You know, the LHC is going to give us a whole lot of data. We have to analyze that data and then try to get the results to the public. Exactly what is the procedure that we have to go through to do that? Let's talk to my colleague and find out.
So this is Tom LeCompte. He's the physics coordinator from ATLAS. What does that mean? How you coordinate the physics of the world's largest physics experiment? What does that mean?
So there are about 3,000 physicists on ATLAS, all of whom have their own ideas of what's interesting to measure and what needs to be measured first. And what we try to do is to organize this in such a way to get the most physics out as soon as possible. You don't want two people working on the same thing if they don't know what each other is doing. You don't want some things completely uncovered because nobody knows that this is empty. So what I try to do is to make sure that everything that needs to happen for an analysis to happen actually happens.
If I were to come to you tomorrow and say, look, Tom, I've got this plot and there's something on there. It looks like it's something new. You're going to have a meeting, as you said. What else are we going to do?
So one of the things that happens is first you go to a small working group of experts in that particular thing. So if you are interested in a particle that's, like you said, the Higgs, there's a group of Higgs experts which first looks at this and says, is this convincing or is it not convincing? And usually there are some changes and checks they'd ask you to make to convince them. At that point, once they've agreed that, yes, this may be real, it goes to the full collaboration, who are non-experts. And they also have to understand the argument of why you think you're seeing something as opposed to not something or something else. And then only when both the experts and the full collaboration agree do we send a paper to a journal and let people outside the experiment look at it. And of course, then each individual physicist who reads this paper has to decide, am I convinced by what ATLAS says or not? So having these internal steps lets us write a paper which we hope is convincing to people who may be following this thing from a different point of view.
So if my colleagues or I think that we've found something very interesting, something that's potentially new physics, we still have to convince a whole lot of people before we can take that result and publish it.
Now, what do you expect to see differently? I guess your work's going to change then. You'll no longer be measuring the old particles, but perhaps have a chance to see some new ones?
What I would imagine, think about it as if you're an astronomer. You now have a telescope that lets you see 3.5 times farther. Right. So one of the things you're going to do is you're going to look at the things that you already know that are there, the moon and Mars and so on, but you're going to see them in much more detail because you now have this much more powerful instrument. So one of the things we will be doing is we will be continuing to look at things that we already know are there, but to get a better picture of them. And the other thing that this powerful telescope lets you do is it lets you look deeper and lets you find new objects that you didn't know were there. So we're hoping that now we've got this increased range, we're going to be able to discover new particles that, hopefully particles we hadn't even expected, and learn something more about nature there. Given a choice between discovering something that somebody has predicted and a total surprise, I'd like the surprise.
So it seems that the first thing we're going to do with our experiment is measure stuff that we've already measured in the past, but with much greater precision. But as time goes on and we gather lots and lots of data and we work really hard, then we can look to find something new. Perhaps the Higgs, perhaps something new that we've never thought of before. We'll find out.